So welcome to this video. I guess I labeled it Hey Niner. Yes, how well do you know your exponent laws? So I created this document, so you will find it actually below in the show notes. I'm going to do a link to this particular file. So if you've watched all the exponent videos, I would want you to try this. So it's a little bit of a challenging kind of a exercise between about 10 different examples where you get to test yourself and see how well you know your exponent laws. And I would recommend that you pause the video maybe now, download it, okay, try to work it out, okay, and then come back to see the solutions. All right, okay, so if maybe you're just continuing to watch, or okay, you've actually tried these questions. Okay, so let's take a look at this particular handout, and that's going to kind of put a wrap on these exponent laws, and then we can move on to some other stuff. All right, so what we have is basically this handout, and there's about 10 questions, so 5 questions each. So the first set of questions, so it states, explain why the answer given is wrong. And then the second set of questions simply say simplify and then place all the exponents positive. Now, you're not always going to be asked to place exponents positive, but I wanted you to try it so that you understand and see if you actually know what happens to the exponents, right? As it goes up and down in the denominator, numerator, okay, if the exponents are negative. All right, so let's come back. Okay, so we'll try this first example. So question number 1, and it gives us the answer. So we have our answer is right here. And then it's asking us, okay, so what is wrong with this thing? Well, what is wrong with this thing is that exponent laws only apply to multiplications and divisions. And notice that in here, you actually have 2 terms. So you have one term, and then here's the other term. Let me blow this up. So you have 2 different separate terms, and they are separated by this addition. And if you look at this, so what this answer has done is they basically took the exponents and they've added them up together, and then they took the exponents on the x variable and then added those together. And that would work if there was no addition sign there, but it does not work once there is an addition sign. So this answer is actually wrong. It's a common mistake which is made by students. All right, so be careful as you're applying your exponent laws. So the exponents only add if you are multiplying with the same base, right? So now because we have 2 separate terms, you cannot go across and just add them up. So that's number 1. Okay, so now let's take a look and see what is wrong with number 2. Okay, so with number 2, so what we have is we actually have something very similar. So notice we have our answer, so 3 and 3, so that's fine. And then we have our denominator. Now in our denominator, so once again, we have 2 separate terms. And this is again separated by an addition in the denominator, and you cannot just simply go ahead and be adding up exponents across. So x to the 2 and then x to the 4 in the other term can't just be simply added. And then the other problem is that you have this 4 right here, and that 4 makes absolutely no sense either. Okay, so the error here is spotted that you have the exponents, and then your actually leading number, the coefficient, can't just be simply placed as it is. All right, so that is number 2. Okay, so I wonder if you've caught that one. So now let's continue. Okay, so number 3. So this one, okay, so this is common error. So notice this is actually one term that you have in here. So the variable that we have, the base is just a. So a lines up, so that's great. So that works fine. And indeed, now we have the exponents, so 9 and -2. And this case, so notice that the answer they put is 11. Well, if you're going to use the exponent laws 9 plus, okay, and it's negative 2, that does not come out to 11, right? It should actually come out to 7. So the answer would have been a to the 7. So that is an error, and sometimes people get caught because of that negative there. So you are still adding them, but okay, because it's a negative exponent, it's going to be subtracting. All right, so that's question number 3. So that's this one. Okay, so question number 4. So what's wrong with that? So I wonder if you can catch this one. So we have, again, so the same variable, we're dividing. So that's great. So we have one term. Okay, so we have a factor on top and a factor at the bottom. Our base is y, so that works fine. So that's okay. But our exponent, not so good. Okay, so it's 2. And this is very common mistake that I would see students would make whenever they are working with these exponents. So remember that the exponent law, because we are dividing here, right there, then what you're going to be doing is you're going to take the exponent 4, and division means it's subtracting, but we are subtracting a negative. So really this becomes negative, and negative is actually positive. So that exponent should be 6, and it should not be 2, which a lot of people will do. They'll say 4 minus 2, and then they'll have a 2 exponent. Okay, so be careful with that one. So that's another good one there. So we have 4 out of the way, and now let's take a look at the last one, which is number 5. So what's wrong there? So notice, okay, so let's see how well you remember the exponent laws here. Notice we do have brackets, and if you have brackets, remember that your exponent will distribute across through the actual exponent inside. So here, this 2, actually I have no idea how they came about that. Maybe they did 4 minus 2, but that definitely is not the case, because the distribution across the exponents, you're going to have 4 multiplied by negative 2. And that would be negative 8. So you would have b to the negative 8. And if you recall, that negative, okay, so it just simply means b to the 8. So that's the mistake there. Okay, so those were the first 5 examples that we had. Okay, so that's just catching the actual errors made. So this was a good one, because very often you're just simply told to simplify and so on, but sometimes, you know, these questions are rather decent to work on. So now let's take a look at the next set of questions. So we have these ones right here, and I'm going to take them one by one. So it says simplify and place all exponents positive. All right. So this actually right here, so I'm going to rewrite it. So a to the 3, b to the minus 2, a to the 5, and b to the 3. So for whatever reason, sometimes students will get tripped up by this, because they notice they have a and b is side by side, and then a and b is side by side again. Now remember that multiplication for numbers is commutative. So you can actually swap them. So really, you can really rewrite this entire thing and just simply say a to the 3. And then instead of the b, I'm going to shift the a to the 5, b to the minus 2, and b to the 3. And people will say, can you do that? You can. It's the same thing as if you would have, let's say, 2 times 3 times 2 times 3 again. So in this case, you can certainly move your multiplications around in this way, because the order is irrelevant when you multiply. So we can do the same thing here. But once we do that, so notice that we have, so these two have the same base, and with the same base, I can just add the exponents, so 3 plus 5. These two have also the same base right here. And now be careful, because it's minus 2 plus 3, which is just simply 1. All right, so the whole answer is a to the 8 and then b. We don't really need to put the 1 exponent there, it's understood. So that would be example number 1. All right, so now let's take a look. And okay, so we're gonna take a look at example number 2. So for example number 2, we have a little bit more complicated. So x to the 11, y to the 4, x to the minus 2, and then at the bottom we have an x, I guess it's to the 1 because it doesn't have an exponent, and then y to the 4. So what I like to do is whenever I apply these exponent laws, because they are actually intertwined here, so you're actually using several at once. So first, clearly we have just one big term. We have all of these x's, so x here, and then x here. And once you know that you have the same base, you know that in multiplication, so in the numerator in this case, what we can do is we can take this 11, okay, and then plus minus 2. Now, 11 plus minus 2 is actually 9, right? So we have, so from here and here, this will be 9. And then we also have an exponent here, which is not really written. So that is 1. And then, so remember, so really what we have is this. We have 11 plus minus 2, that's on top, minus the 1, which is coming from the bottom. So in that case, this would simply be 8. So it is x to the 8. So that takes care of that base of x. Now, what about the y? So be careful here, because with the y, what we have is, so we have a y, the 2 exponents there. So I'm going to actually write it. So this is 4 on top. We are dividing, so it's minus, but it's minus negative 4. So the negative and negative becomes positive, so this becomes 8. So the answer is actually that. All right. So this is what we have. So far, all the exponents are positive, so we really don't have anything else to do. So that was question 2. Let's take a look. So here is another one. All right. So let's take a look at question number 3. So we have, let me just copy it down, maybe. Okay, so paste this, and I'm going to make it a little bigger for myself. All right. So now a lot of stuff is happening. Okay, I do have brackets here. So because of the brackets, notice I have brackets right there. So I'm going to first simplify what's inside of the bracket instead of worrying about this 3 exponent which is outside. I'll apply that law at the end. So I have inside of my bracket, so notice 2 of the same base, so c. So I'm going to start with that. So c, and now negative 2, and it is division, so it's minus 11. So I have negative 2 minus 11, which becomes negative 13. So that's for the c. Now next, so what I will have is, now I'm going to worry about the d. So now with the d, so I have d. Now don't forget, so I do have an exponent there, so it's d to the 1. So that's 1. Again, it's division, so I'm subtracting. So 1 minus 4, which is negative 3. So what I have is this. Okay. Now next, I'm not done. I have to distribute this 3. So I'm going to distribute it across. So it's going to multiply exponent, and then it's going to multiply this exponent here as well. So this is going to become c. So negative 13 times 3 is negative 39, and negative 3 times 3 is negative 9. So now I've simplified this, but because they ask for a positive exponent, so this is a good test for you to know that this is exactly the same thing as saying c to the 39 and d to the 9. So notice that I brought the negative exponents down. So that's what happens, and you can rewatch the exponent law if you wanted to. Okay, so that particular video. So I'll put a link to it as well so that you have it. Okay, so that was question number 3. So let me remove these right here. So let's delete this stuff. Okay, and we'll delete this one, and now I'm going to take question 4. So let's take question number 4. And again, so it seems that it's getting a little bit more complicated. So what do? Well, I do have these brackets here. So, you know, can I simplify anything within the brackets? Not really, because I have 2 different variables. So x and z. And then in the other one, I have y and z, or z, depending how you pronounce it. So for this one, so the best thing that I can do is I can actually just take my exponent and I'm going to distribute it across here. So I'm going to get x. This is going to be 3 times 2. And z 4 times 2. So that's the first one. Okay, so that's all of this junk. Now I'm going to take the next one. So this one right here. And I'm going to distribute. So again, so don't forget, there is a 1 exponent on the y. And then also do it on that. So I have y, 1 times 3 is that. And z or z, so that's going to be minus 6. All right, so this is what I have. Now, as I've distributed that across, I have no x's, okay? I have no y's, so those ones are independent, but I do have the z and the z here. Okay, so again, so my x, so nothing changes. Okay, so my y, okay, so nothing really changes there. Again, the order doesn't matter. I'm actually putting them in alphabetical order. And then z, so notice it's 8. Okay, so here, and we're going to be adding these 2 exponents. So 8 plus negative 6. Okay, but the positive and negative is actually a negative, so it's a subtraction. So this is going to be a 2. And that would finish that off because we can't simplify it any further. All right. So how are you doing so far? Okay, so these ones are a little bit more challenging, and they really kind of push your button to see if you understand the exponent laws or not. Now, the last one, this one I actually took from the previous question. So if you notice there, this one is nice and simple, or much simpler. So for this one, b, and then all you're doing here is you're just going to distribute, right? So you're multiplying, so this is going to be negative 8. And if you want to have a positive exponent, so this is going to be that. And that's exactly what we had when we were doing that above. Okay, so for that explanation. That's it. So if you can do all of these and you understand them, then you are pretty good with your exponent laws, right? So if you want, you can rewatch the videos on exponent laws. And if you understood this, well, welcome to grade 9, I guess, okay, or whenever you started to study this. Okay, so thank you for watching. Okay, peace out. Cheers. Bye.